Let's look at angular distance, distance, and linear distance mathematical calculations in astronomy. Here we have an image posted on Astronomy Picture of the Day, August 25th, 2016, and we are looking at two different constellations, Centaurus and Circinus. We are also looking at a gravitationally bound star complex of several different stars, two of which are labeled. We have Proxima Centauri in orange and Alpha Centauri labeled in the yellow color. They are separated by a linear distance. That means a straight line distance, a linear distance labeled in the orange color. And they subtend an angular distance between the two stars, which is indicated from the observatory to Proxima Centauri red line and the observatory to Alpha Centauri red line, the angle of which subtends this yellow curvature line, which we have labeled alpha. That is your angular distance between the stars. Now, the distance to the complex of star systems is indicated by this yellow dashed line. That is the straight line distance from the observatory to the gravitationally bound system. So let's look at a problem. Let's say that we want to find the angular distance between stars Proxima Centauri and Alpha Centauri given the distance of 4.234 light years to the system and 11 AU linear separation distance between the stars. We want to find the given, which is the distance to the system is 4.234 light years, and a linear distance between the two stars of 11 AU. That's the straight line distance. Now we want to study the question and find the find part of the problem. We want to find the angular distance alpha, this angular distance in the sky separating these two stars. Since we are finding the angular distance alpha and the question does not specify whether it's degrees, arc minutes, or arc seconds, we can choose any of the three equations in this chapter that we would like to use. Because the distance looks pretty good, meaning that we see a wide separation, we're going to use the degree calculation. Equation 1c. Now this equation is where we're given alpha degrees divided by 57.3 in units of alpha per radian, or degree per radian, which is equal to the linear distance divided by the distance. Now we are given the linear distance and we are given the distance. So we can go ahead and substitute these two in to the right-hand side of this equation. So here we kept the left-hand side the same. Alpha in terms of degrees, that's our angular separation. 57.3 degree per radian is our conversion, and that is equal to 11 AU, which is the linear distance, divided by the distance of 4.234 light years. Now notice that we cannot directly calculate the right-hand side of the equation because AU does not cancel with light year, LY. The letters must cancel in addition to the numbers. Since we can't cancel, we must convert. Now we could have converted from everything into AU or everything into light year, so long as the top and the bottom remain the same. I decided to use the conversion of 1 light year is equal to 63241 AU. Therefore, I can cancel AU and I can cancel light year. And now that my letters have canceled, I can now solve numerically the right-hand side of the equation. We need to take 11 times 1, divide that by 4.234, and then divide that by 63241. So let's go ahead and do that. So here's our Google calculator, and the first step we need to do is 11 times 1, and then divide that by 4.234 equals. And now we need to divide by 63241. So we divide this by 63241 and hit the equal sign. And now we have this very small number. So now I've replaced the right-hand side of the equation by that very small number, 0.00004108. Now we need to multiply by 57.3 to both sides of the equation. So when we multiply both sides of the equation by 57.3 degrees per radian, we can cancel out the ones on the left side, and we'll be left with just alpha in terms of degree, which is equal to this number over here on the right. So let's go ahead and do that. So we have to multiply 57.3 by that very small number. So let's go back to our Google calculator. So now we're going to multiply by 57.3 and hit the equal sign. And now we've got a better number, 0.00235, and then we can round these guys up. 95 is greater than 50, so we can round this one up to 4. 0.2354. So our answer in units of degrees is 0.002354 degrees. This is a very small number. Let's convert it into arc minutes. We know that the conversion is in 1 degree is 60 arc minutes. So now we can cross out degree and multiply by 60. So let's go ahead and multiply our answer by 60 on the Google calculator. So now we multiply by 60, hit equal, and now we have an answer of 0.141. And notice that 23 is left at less than 50, so let's leave it as 0.141. So our answer is 0.141 arc minutes. The degrees cancel out, and we're left with the little arc minute symbol. So our answer is 0.141 arc minutes. We could have said that alpha degree is just 0.002354 degrees, but we converted into arc minutes, so now we can say that alpha of the degree is 0.141 arc minutes. So this separation distance in the sky is 0.141 arc minutes,